Hello students, good morning to all of you. So here today we are going to start the remaining concept which is given or which is present in first order reaction. Continuation we are going to discuss. Okay, so first in the last class we stopped at ln r is equal to minus kT plus ln R naught initial concentration. So we stopped up to here. Now continuation, the continuation for this. Here we are taking, here see, ln R minus ln R naught is equal to minus kT. So now both sides I am multiplying with negative, minus. So then it will become as like ln R naught, you can take initial concentration minus remaining concentration after t time is equal to kT, because both sides I am multiplying with what? Negative charge or nothing but a minus. Both sides I am multiplying with minus. Okay, so then the above equation is changing like this. Is it clear? Now we can write like this: ln R naught by R is equal to kT, we can take like this. Is it clear? So is equal to kT, we can take like this. So but everyone should remember here one ln is equal to 2.303 log 10. You all know very well ln means what? Ln means nothing but a log base e. Okay, so now this log base e we are converting into log base 10. If you want to convert into log base 10, you should multiply. We should take like this. Is it clear? Both are similar, both are same. So they are representing with ln. You can also represent with log e. Have you got it? So this term I am going to substitute here. So now here what is this? Now here you can take 2.303 log of base 10 R naught by R is equal to kT. Have you got it? So now T comes this side. Therefore, final step. You can see that final step K is equal to 2.303 by T log base 10 R naught by R. This is the final integrated equation for the first order kinetics or first order reaction. Have you got it? So in the last class we plotted graph for this one, this equation. After that continuation. Have you got it? So continuation we can take one stepwise. Is it clear? This is integrated equation for the what? First order reaction. So now we need to plot a graph for this. Okay, so now to plot a graph for this, what we have to take? So I am taking this equation, this one. Both are similar, but I changed it with respect to log. Okay, so now here we need to plot a graph for this. So how can we plot? Or else you can draw for this, nothing will happen. Okay, no problem, you draw for this graph for this one. Here you see this, just a small change I am taking here, that is log of R naught by R. So T and 2.303, this term I am taking this side. Okay, so now what will come here? Here automatically kT by 2.303. Okay, you can write like this, that equation. So here if you take like this, here just you take plus 0. Okay, now compare that equation with y is equal to mx plus c. So now I am taking here y is equal to mx plus c. Now here you see this y-axis, x-axis I am taking. Okay, so y-axis, if you take, on the y-axis we have to take log of r naught by r, log of r naught by r on the y-axis. Is it clear? Now here you can take on the x-axis we have to take time. On the x-axis we have to take time. So now here you see starts from 0. So this is the graph for what slope? What is the slope for this? So slope for this one is k by, can you see this? Okay, k by 2.303. Okay, k by 2 slope this is it clear? Simply this is the graph for what? Integrated first order integrated rate equation. Clearly you can see this one by one. So in the last class, in the class number 6, we stopped up to here and we plot a graph for this also. Have you got it? So now here after that first order integrated rate equation derivation, continuation for that. So this is our final first order integrated rate equation. For this we have to plot a graph. So we plotted graph like this. Is it clear? Any doubt once you see and follow? Is it clear? Now you may ask, sir, can we draw for this? Yes, you can also draw for this. Okay, so we plotted graph for this, okay, which is converted into log base 10. You can draw for ln also, nothing will happen here. You can draw for ln also. Here you take what? Ln r naught by r plus is equal to kt plus 0 you take. Here you compare with y is equal to mx plus c. Same thing, but here slope is what? Here you have to focus. Slope is what? Slope is equal to what? K. Okay, only k will come. Where if you draw or if you plot a graph for this equation, slope is equal to k. Have you got it? Positive. Okay, so like that we have to take. Any doubt in this? So clearly you can take it, take a snap. You can draw for this and you can draw for this. For this, slope is equal to k. For this, slope is equal to what? K by 2.303. Take it down, take a snap for this. Okay, after that we can take, so next one. What is that next? Exponential factor we have to take. What is that exponential factor? Before going to learn about exponential form, before going to know about the exponential form, we need to focus. Now here you see. So I want to give you clarity on this form. Here see k is equal to 2.303 by t log what? R naught by r we have taken here. So in these terms I want to explain to you terms. What are the terms? Okay. So clearly I want to give you. So I am taking reactant R gives product. Okay, products. You take like this. Okay, so first initially time is equal to 0. If initially time 0 means R is equal to concentration of reactants, initial concentration, R naught, initial, products 0. But next time T, time T. After T time, reactant concentration decreases, products concentration increases. So here you can see this R naught minus X. X quantity of reactants concentration decreases, that same quantity increases. Okay, after T time. Now what I want to explain to you is R naught is a initial concentration where time T is equal to 0. Okay, here R naught minus X is equal to remaining concentration after T time of reactants. Okay, after T time, remaining concentration. Is it clear? So now this one we can take it as like R, which is given in the what? Which is given in the reactants. Have you got it or not? Okay, here in the formula, R means remaining concentration after T time. Don't forget about this. Is it clear? So this is total expression. Here you see K is equal to rate constant. T is equal to T time. A R naught is equal to initial concentration where the time is equal to 0. Okay, so R is equal to remaining concentration of reactants after T time. So R naught minus X is equal to R. So this value we will substitute here. Then we will get that full form. Is it clear? Now sometimes they will give you intermediate data. So intermediate data, that means here first they will give T1. Okay, up to here clear? Now here see, after this we need to focus on the one major point. What is that? Say K is equal to, what is that? 2.303 divided by T2 minus T1. T2 minus T1 log of, okay, R1 minus R1, sorry, by R1 by R2. So this formula. So what is this? Sometimes they won't give initial concentration. They won't give initial concentration. They'll give what? Concentration R1 at T1 time, concentration of reactants R1. Okay, you can take R1. So at T2 time, concentration of reactants R2. You can take like this, R2. Have you got it? Is it clear? So these are two intervals. So time. This formula we use while solving the problems. Here mostly it's useful because they won't mention about anything related to initial concentration. So at T time its concentration will be T1 time concentration of reactants will be given, and at T2 time reactant concentration. Okay, so in this case if they give like related information, we have to use this formula. Have you got it? Any doubt in this? Just take it down, this one. After this we have to have exponential factor or exponential form we need to learn. Is it clear? Very important. So while solving the problems we have to use this one. We will solve problems also in this concept. Okay, up to here clear? So now here you see that next one, exponential form we have to take. So what is that exponential form? Exponential form. So what is that exponential form we have to take? So here you know ln R naught, this relation you know very well, R naught by R is equal to, what is that? KT. You know, in the previous step we have discussed about this. Now what we are going to do is just both sides I am multiplying with negative and nothing but a minus. So whenever you multiply with here ln r will go upside. So therefore ln r by r naught, because both side you are multiplying with minus. So that is equal to minus of kt. Minus of kt. Have you got it? Minus of kt. So right. So now minus kt. Now here I want to tell you one logarithm formula. So what is that logarithm formula? You know very well. ln a is equal to b. Okay, ln a is equal to b. Now here you see, if you take, then a is equal to e to the power b. Then a is equal to e to the power b. So this formula, this application we are going to use. You see this form we are going to change to this form. Here see ln, this one is there, no? We are going to change r by r naught is equal to, okay, e to the power what? Minus kt. Have you got it what I am saying here? So we have used this formula. Is it clear? Now finally this is called, we can write it, r is equal to r naught into e to the power minus kt. This is first order reaction, what? Exponential form. Okay, first order reaction, exponential form. So you have to take it like this. Exponential form, we should have clarity on the exponential form. Take it down, all of you, clearly you take it down. Okay, so right, exponential form. Right. So after this exponential form, next we are going to focus on the here first order gaseous reactions. We have to focus on the first order gaseous reactions. Okay. So what are the first order gaseous reactions? So what is that integrated equation for that? So now very easy and major point you see here. I am taking a gaseous reaction. What is that gaseous reaction? A gives B plus C, and I'm writing here this is a gas. Okay, whatever it is, it might be gas or not, that's not an issue. Okay, you take it like gas. Okay, it is a gaseous reaction. In the gaseous reaction we cannot use what? Concentration. So gaseous contains pressure. Okay, so partial pressure or pressure contains, they never contain concentration. So it's a gaseous reaction we are taking. In the gaseous reaction, here clearly you take time 0 initial, where time t is equal to, or time is equal to 0. Initial pressure of reactants, I am taking it as like Pi. Okay, products 0, because initially reaction is not at all started. That's why whole pressure, initial pressure of the reactant A is Pi in 0, 0. After time t, okay, we are taking after time t. What happened here? Some pressure of reactant X decreased. Okay, so now that is here increased. Have you got it? Okay, so now you can take like this, Pi minus X, here decreased pressure, here increased pressure. Is it clear? So now we have taken this expression clearly. Now what I am going to tell you is P total. Here you have to take P total is equal to what? Pi minus X plus X. P total means all. At T time, total pressure is equal to what? Total pressure Pi minus X plus X and plus X. Now here you see the cancellation you can take it like this. So therefore, here PT means total pressure, is equal to Pi plus X we can take. But we need X here. So how to calculate, how to find it out X? X is equal to what? This, it goes this side. PT minus Pi. Okay. So X is equal to PT minus Pi. So up to here, any doubt, once you see from here to here, any doubt you can ask me. Okay. So no doubt. So now here, now what we are going to do is, you know, integrated rate equation for the first order formula, you know, that is K is equal to, okay, K is equal to what? Here K is equal to 2.303 by T log R naught by R. You can take like this. This is for concentration terms. I have given in terms of concentration. Okay, sir. But this is what? Pressure, no? So here you have to take. So this is very, very important. Initial pressure is equal to initial pressure place you have to take. In the initial pressure. R naught place, initial pressure you have to take. R place, what do we have to take here? R place, Pi minus X we have to take. In the R place, Pi minus X. So now here Pi minus X, how to calculate? X we need to remove, no? So here see, Pi minus X is equal. What is meant by X here? You have to take X is equal to Pi minus of PT minus Pi. This minus goes inside, Pi minus of PT, can you see this? Okay. PT plus Pi. So therefore, totally it will become as like a 2Pi minus PT. 2Pi minus PT. Is it clear? So now this is what? R. You can take it like this. Okay, remaining pressure after T time. Okay, so you substitute these terms all. Initial pressure and next one, this one. You can see this. Now, so I am going to substitute in the concentration term, pressure terms I am going to substitute here. Final equation we are going to get. K is equal to 2.303 by T into log of initial pressure Pi divided by 2Pi minus PT. Have you got it? So this is our what? Integrated rate equation for first order gaseous reactions. Okay, so first order gaseous reactions, integrated rate equation. So take it down clearly one by one. Any doubt in this you can ask me, no problem. Okay, so take it down one by one. Okay, right. So take a snap or else you can note it down. Is it clear? Okay, done. Any doubt in this? Clearly you see this one by one, step to step, clearly. Okay, right. Done. Now after this gaseous first order integrated rate equation, we need to learn about half-life. So here you see this half-life. Okay. So half-life, what is the half-life? You know, we have discussed already. Where in zero order, half-life. So what is meant by half-life? You know, initial concentration should become half of its initial the time taken to become half of the initial concentration is called as half-life. For example, I gave 100 grams. So 100 grams of reactants. How much time will it take to become 50 grams? Okay. Okay. How much time will it take to become 50 grams? Okay. That is called half-life. So simply half-life terminology, T is equal to, we can take T half. T is equal to T half. Okay. And concentration R means what? Initial concentration should become, it's a half. You have to take half-life. What is half-life? The time taken to become initial concentration into its a half is called as half-life. Half-life we represent what? T half with this expression. Okay. So according to our concept, now take that half-life into our first order integrated equation. In the first order integrated equation, here T is there. Here T place, what do we have to substitute? T is equal to T half, half-life. Whenever T is equal to T half, what will happen here? R is become R naught by 2. Okay. R is equal to R naught by 2. Right. So now here you see this. I am going to substitute these values in this form. K is equal to 2.303 divided by T place. What do we have to substitute here? That is T half into log of what? R by R naught. R naught by 2 you can take. Okay. R naught by 2. R naught get cancel. You see here simply R naught get cancel. Okay. So now these two come upside. You see this one. Therefore, can you see this? Oh, okay, done. So K is equal to here 2.303 by T half into here 2 comes upside log 2 base 10. You know very well this is base 10 only, no? So log 2 value, you all know very well, log 2 is equal to 0.3010. Okay, how to remember all log values? Okay, you can see in our channel, very simple manner I made a video, just it's a 2 minutes or 4 minutes video, just you focus on that. You can remember all log values without using logarithm book. You can solve log models. Okay, so I gave that one in our what channel, you can search in playlist. Now here you see, so instead of log 2 I am going to substitute here. This T half I am taking this side and K is going towards this side. Okay, are you able to follow? Okay. Okay, just you give thumbs up. Don't forget about that. Give thumbs up. That means like thumbs up Pepsi, not like that. Okay, so it's a value you know, that is divided by K. Okay, so final point. You see this T half. Can you see this? Okay. T half is equal to, or else I will write upside, that's better. T half is equal to 0. Overall value 693 by K. 693 by K. Okay, take it down. This is half-life for what? First order reaction. Okay, so here you take this one like this. Done? So here I want to tell you, first you take down this one, take it A to Z in clear cut manner. Any doubt you can ask me, I will tell you, no problem. I am here to help you for your competitive examinations for like IIT JEE and NEET. Okay, so take it down, and I want to give you graph for this also. Graph is very important. You have to have clarity on the graph. Is it clear? So now after this point, so next you can see this. You can see this. One important point. What is that important point, sir? important point is T half is not depending on the concentration term. See, T half is equal to what? 0.693 by K. Is there any concentration term? No, there is no concentration term. Have you got it? No concentration term. So that's why first order half-life is independent on the concentration of reactants. First order half-life is independent on the concentration of reactants. Okay, so here you see that graph. So graph, you take the graph. Graphs are playing very important role. Okay, for JEE mains purpose. Okay, so now what I am going to take here is concentration of reactants. You take reactants, concentration of reactant, you can take like this, concentration of reactants. So here you take half-life. So have you seen any relation with concentration of reactants? No, there is no relation. Have you got it what I am saying? There is no relation, there is no concentration term. This is also constant. Half-life is constant. Which half-life? First order. Okay, first order half-life is constant. Okay, so now graphs, you see how we are getting here. The graph is coming like this. Okay, it's a straight line because it's not at all depending on the concentration term. So nice point, no? Okay, nice point. Take it down, this one. Okay, right. This is a graph for half-life. Okay, done. So after this, I am going to give you excellent point. After this, you can take this one. After this, we need to focus on one more important point. One more important point. What is that? Okay, keep it like that. I don't want to disturb and I don't want to wipe. Right? So now here see, next one, lifetime. 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 What is lifetime, sir? Lifetime means 100%. No. Lifetime means 100%. How can we represent this lifetime? How can we represent this lifetime? Simply T 100%. T 100%. So lifetime is nothing but T 100%. We can represent. So lifetime. It's done. So now how can we represent? How can we find it out? Lifetime for first order reaction. Lifetime for first order. Don't forget about this. Lifetime for first order. Here you see this. Here then you know integrated equation for first order. So it is always we are using this one. K is equal to 2.303 by T log of R naught by R. Here what's a major point? T is equal to what do we have to take here? T 100%. Okay, T 100%. And next one more point I want to tell you. R. R means what? Remaining concentration. Remaining concentration. Remaining concentration is what? Remaining concentration of reactants after lifetime. 0. That only, no. We have to take 0. Reaction completed means according to our imagination, reactants are 0. So remaining reactants after lifetime is 0. So that's why R I am taking it as like 0. T I am taking it as like lifetime. Okay, after lifetime whole reactants will be converted into products. That is our imagination. Okay, so that is our activity, general taking. We take like that generally. So now here I am going to substitute these values here. Okay. Now K is equal to 2.303 by T 100%. Okay, just I want to change that one like this. Here you see, this K I am taking this side, this T I am taking this side, this K is going that side. So here you see this T 100% is equal to 2.303 by K into what? Log base 10. Initial concentration or not, we can't change it. But R value is what? 0. Because after what? Lifetime, reactants concentration becomes what? 0. So therefore, here 0. You people all know very well, anything by 0 is equal to infinite. Have you got it? So T 100% is equal to infinite. Have you got it? That means lifetime of first order reaction is infinite. Have you got it, dear? So focus here clearly, lifetime. Okay. So but here you see T half-life is constant. T lifetime for first order is infinite. So clearly you can take all these things. Point. Is it clear? Any doubt in this? Once you check it, take it down, take a snap. Okay, done. Okay. So now after this point, I want to tell you one major point. What is that major point? Okay, so now we have to compare, because according to our syllabus they focused more on the zero order and first order. That's why you should have clarity on the both. Okay, here you see T lifetime 100% is equal to infinite. You can take like this. Okay, done. You can take like this. Okay, so now I want to compare the half-lives of what? Zero order and first order. Have you got it? I am going to compare, okay, half-lives of zero order and first order. So clearly you have to focus. I am taking zeroth order, here zeroth order, and here you take first order. Compare just half-lives only. I am not taking all those things and points. Here half-life formula for zero order, T half is equal to, what is T half is equal to? R naught by what? 2K. You know, in the last class, I think class number 5, okay, we derived it. Class number 6 or class number 5, yeah, we derived it. So now here half-life for what? First order 0.693 by K. So now everyone should focus one major and important point, that is T half is in zero order directly proportional to the concentration of reactants. Have you got it? Directly proportional. But here you see this, T half is constant. Okay, constant. Have you got it? So what a simple logic, simple point. Have you got it? Half-life is directly proportional to initial concentration. Initial concentration increases, half-life also increases. Here it's not depending on the concentration of reactants. Initial concentration here depending, not here. Have you got it? The gap, the point, is it clear? You should have clarity on this. I have given clearly about the graph for this and graph for this also. Okay. After this, you should have clarity on one more point. What is that? Is it clear now? Now, after this, we need to focus on the next point. Next point, if you take zero order. So zero order rate is independent on the initial concentration. You should have, just you know this, but again I want to compare. Okay, see, reactants hold the power 0. That means rate of zero order reaction is constant. See what a difference and nice points. But here you see this, a rate is equal to K into power 1. Because it's a first order, it's a 0 order. Have you got it? So clearly it's a 0 order. R to the power 0 is equal to 1, therefore rate is equal to k. Okay. Now rate is equal to k. It's a first order, no, R to the power 1. So now what is happening here? Rate is depending. Rate is depending. It's a directly proportional. Okay. So you can take it like that. So rate is directly proportional to the concentration of reactant. So this point you should have clarity. Okay. So rate is constant in the 0 order. Okay. Good morning. Good morning. Okay. So now, but whereas coming to the first order, rate is directly proportional to the concentration of reactants. Is it clear, dear? So do you have clarity on the 0 order and first order? Okay. Now coming to the next, we have to solve 1 or 2 problems. So basic 1 or 2 problems we have to solve for on the first order. Okay. Again we will solve many problems on the chemical kinetics, all topics. But basically, first for your understanding purpose, I want to we have to solve some problems on the first order. Okay. So we use only these 2 according to NCERT. According to NCERT, they gave only these 2. This is for your knowledge purpose and JEE purpose. It's very useful just to keep it in your mind. But while solving problems, we use this one and this one. Is it clear? Right. Have you taken this one? Okay. Now I'll bring problems and we will have a complete discussion on those. Okay. So now I want to take problem. So if you take down, so take down that problem. For the first order reaction, half-life is 6 minutes. So first problem just you take. For first order, time waste total I am not writing. Just I am writing only needed given information. Okay. So you can write it. For a first order reaction, half-life is equal to, T half is equal to 6 minutes given. Calculate the rate constant of the reaction. That means they are asking about K value. Very simple, K value. Okay. Here you see this formula should be used here. Very simple, directly. K value means K you take this side. So you know this, K is equal to, directly you can write 0.693 by T half you take, and T half value is given, K is equal to 0.693 by 6. Okay. So just cancel it. If you cancel it, you will get it 0.693. By the cancellation here, 0.115 will come. Just you do it. Here minutes. You can take minute 10 bars. Take it down. Is it clear? So this is one simple model. So they'll ask for K and they will give half-life. For some time they will give what? K value, sometimes I am saying about, sometimes they'll give K value and they'll ask half-life. So we have to take like that. Is it clear? So now coming to the next model. So next model question, it's a little bit 2 formulas we need to use here. So now take it down. Next model, question number 2, you can take question number 2. So first order reaction is completed, is 90% completed, 90% completed, 90% completed in 40 minutes, in 40 minutes, 40 minutes. Okay, calculate half-life, calculate half-life. So here in this case we need to use total, what 2 formulas we need to use here. So if you want to use these 2 formulas, first given data is given here. 90, first initial concentration you take 100 or not, 100 you take. Okay, 100. So now what happened here? 90% completed. 90% completed means remaining is how much, tell me? Remaining is 10 only, no? So R is equal to R remaining concentration after 40 minutes. 90% completed means remaining is 10 only, no? So therefore 100 minus 90, you can take like this, 90% 10. Okay, so now, okay sir, R value, okay. Sir, why do we have to take R and R naught and R, sir? Because first we have to calculate K, because they are asking for T half. If you want to calculate T half, here we need to use this formula. In this formula, K is there? No. K, how can we calculate K? We can calculate K from this formula, with this formula. So that's why the given data I am substituting in that formula. K is equal to what? 2.303 by what is that? 40. T is equal to 40 minutes into what? Log of 100 by 10. 100 by 10. Okay. So 100 by 10 you can take. So 100 by 10, 0, log 10 is equal to 1. You all know very well. So very simple one, log 10 base 10 is equal to 1. So here finally what did you get here? K is equal to 2.303 by 40. You got K value. Now what do we have to calculate? Half-life, no? So half-life if you want to calculate, so here you see this, T half is equal to here 0.693 by K value I am substituting here. Okay, so K value I am substituting. What is that K value? The 2.303 by 40 goes upside, no? Into 40. Okay, so can you see this? Okay, 40. Overall answer you can take 12 minutes. 12.03 will come. You can take 12 minutes. 03 minutes you can take. Is it clear? So any doubt in this? You see this clearly? Okay. So like this many models are there. Not only one or two, many models are there. So we will solve it. I think it takes some time. So in the next coming classes we will solve many questions from this, and we are going to start next lessons also. Continuation daily I want to take. Okay, so here you see this whole problem. Nicely they gave this data. So this data first we have to calculate K value. Okay, they are asking about T half. If you want to calculate T half, K value we need. So K value we can calculate with the help of this formula. Initial concentration is 100. Remaining concentration is 10. Why? Because 90% completed. Remaining concentration is 10. Okay, that remaining 100 by 10 cancellation, log 10 is equal to 1. So if you substitute, K value is equal to what? 2.303 by 40. 40 is equal to time. Okay, time. So this value I am going to substitute here. T half is equal to 0.693 by 2.303. 40 goes upside, no? So here it like finally, so we will get the answer. Half-life for this reaction is 12.03 minutes. Okay, so this is about our today's class. We will have in the coming classes remaining factors affecting on the rate of reaction. Okay, so till then, bye bye. My request to you is try to share our videos, the people who are preparing for JEE and NEET. So now I am trying to do many videos on that concepts. Definitely these are useful for them. Okay, so thanks for watching again. Bye bye.